Hi. So, my name is Diego Reporgiato and I'm going to present SHELDON, Semantic Holistic Framework for LinkeD ONtology data. So, some of you might know anyway the SHELDON, the Big Bang Theory, the American movie, American series, where Sheldon is basically the main character. And for those who doesn't, basically, who Sheldon is basically he's a nerd and he said he knows everything. So here we try to claim that our system, Sheldon, try to know everything. And yeah, I just put the link down there. So Sheldon is a framework, and it includes several tools, several semantic tools that we developed in the last 2 years, and then we actually integrate them all with other features, other graphical features and capabilities. Here, this is the main, this is the Google-like visualization of Sheldon, and in input, he asks for some text. It might be one sentence, more sentence, or even a document. Actually, you can see the tab on the right where you can even upload a document in a Word, or it could be a Word document, a PDF document containing some text. And, or you can even just type some text. And one of the capabilities that we included is actually the multi-language support. You can write text in any of 47 different languages, and we have a feature that automatically identifies the language. We will translate it in English, and it will work in English, because English is basically the language that we keep all the time. What you can, here in this example, I just put an Italian sentence saying the Garda is the most beautiful city which makes part of Italy. And we have the button just down, you can see where there is a mouse over on machine reading. Machine reading is the first of our component, and what it does, it produces an RDF. Here is actually the HTML format of the graph, but you can even select and get RDF, Turtle, and any kind of format of RDF. And in this graph, which is actually an interactive, so you can click on the link, on the relation, on the property, and it produces this graph. This component is built on top of Fred, Boxer, CNC. It uses event detection, semantic row labeling, FrameNet roles, first order logic representation using the discourse representation theory. It does also modality detection, tense representation, name entity recognition using TAGME, word senses ambiguation, and it also uses DBpedia, and actually identifies entities as DBpedia. In the graph you see actually Riva del Garda in red, and you'll see, which is, it's red because it is recognized as an DBpedia entity, and there is a menu that I'll show in the demo what this menu works, what this menu is. On the bottom right of the slide, sometimes I put REST API and just an icon saying published, because that means that this component has been published in either top or journal or conference, and it's also provided with REST API. So we provided REST API access for Sheldon and also for each component, and people are using them, and I'll show in one of the final slides how many people are using it. This is the second component that we have, and it's the semantic sentiment analysis. So here, actually, I want to say a few words about it. When I first joined Semantic Laboratory of CNR, was July 2013, I basically came from US and I was working on sentiment analysis. I've been working on sentiment analysis for 5 years, and I even opened a startup in US on sentiment analysis. But all the time we were actually struggling on finding the best precision of the methods. And actually we were only using lexical resources. We were using dataset, classifiers, artificial intelligence technique. What we really missed was something related to the semantics. So when I joined the Semantic Laboratory group, and they show me their system, one of them actually Fred, which is kind of similar to this one, to the machine reading component. It came clear to me that I could have used all the semantic information provided by machine reading in order to improve the sentiment analysis. So in 2 months, we built a system which we called, well, it's a semantic sentiment analysis system, and we found out actually that it's included and it's classified as a scientific computing approach. There is this new system, this new area of research which basically they use semantics for sentiment analysis. We built this system and we published 2 papers into magazine because the idea was just to use the semantics provided by machine reading in order to assess the order detection, topic and subtopic detection, the propagation toward entities. We even actually built a new lexical resources which we called SentiNet, and it was really highly appreciated by the sentiment analysis community. In this graph, there is actually, for the same sentence was a beautiful thing about Riva del Garda. You can see the positive score related to the node Riva del Garda anyway. A third component is the relation discovery. Of course, same sentence, same input sentence about Riva del Garda, and it will pop up to you the 2 DBP entities about Riva del Garda and Italy, the type of Riva del Garda, and Italy. And then there's this new relation, which is actually Fred column from part of. This is a binary relation, which is discovered based on the Fred's graph, only among identified entities, of course, DBP entities. And also what we had was a layer of formalization. I mean, we formalized the discovered properties in terms of range and domain using WebP and OWL to property chains. We also use Watson API and of course WebP. One more tool is about the citation typing. Here, what you do is you just type a sentence that you find in research paper where they say actually there should be a citation in the sentence. And what it does is it uses the Fred's graph, look at the event. Event is usually identified as with a verb. Then we look for synonym of this verb. We look in the ontology, which is an ontology with all these property and relation of research papers, and we try and we get the highest match of the relation. And actually, the output you see down here is the name of the property closer to the sentence that I click on, which is not written here, but I'll show you in the demo. And yeah, this purpose, I want to just switch and show you the demo. System is online. You can access it, but we prefer to take a video just in case. Yeah, Murphy is always present. So, and okay, yeah. Let me just go back a little bit. So here is actually the main interface. Okay. Here we just type the sentence. Here is the graph provided by the machine reading component. Here we are playing with the graph. We just mouse over on the DBP, the entity Riva del Garda. There is this menu, and we want to explore it further with this other component, which is a knowledge exploration of the Riva del Garda. Let me just stop for a second. And this is another component which will show you the type of Wikipedia most common and most linked to the type of Riva del Garda, which is settlement. And it will show you this graph. You can I mean, we just click on town, and it will identify and show you the entity related to the type town. And this town here is actually related to Riva del Garda. Why? Because in the Wikipedia here we found Riva del Garda is here, and in the same piece of text we have also the component of the town. Belgium is city in Germany, yes. There are other things that you can do playing a little bit with this. Actually, you can click on this link and it will show you all the types not really common to the type of Riva del Garda. So it's again, it's exploration of knowledge. Another, yeah, going back to the main machine reading graph, you can click on another visualization, which is here. We are clicking on these correlations with Lego. And what it does, is basically looking at this other view, this other component. It will basically get the information from Wikipedia. The subject is still Riva del Garda, and the object, all the wiki links found on Wikipedia page where there is also, Riva del Garda is also present. And what we do one step more. We try to assess a new property between the subject and object in the sentence where both subject and object are present. This property, these properties, something is recording.
No, it's because you're so close to the mic,
okay.
We can hear you beautifully next door.
Okay.
So if you could step a little bit away from the mic,
Sure,
it would be
sure.
awesome. Thank you very much. And we're enjoying the other talk and your talk simultaneously.
So in here, anyway, we can see the we play with the graph. There is the As quality property. We can see the ontology defined using culture. We can go back and see the different kind of visualization of Sheldon. One is this. It's a radial graph. We use Java Infobox tool. And another one is actually, it relies on top of RelFinder. So we built just a piece of code that basically gets the DPP entities from the graph, and it basically they show them on RelFinder view, which is actually this one. And I don't know if you know RelFinder, but once you have identified the DPP entities and you have identified what kind of data set to look into, it will just pop out the graph with other knowledge that we can integrate back in the other components. So then, this is about the machine reading. Then we can play again and just do the same thing with the sentiment analysis component, and it will pop up the graph that I show in the slides, and he is still interactive. And just go a little bit forward as the time is running out. Relation discovery, same thing, just click and get the output that I show in the slides, and again interactive, you can play, and you can actually click on the property and it will pop up the ontology related to that property. And then the last one was actually the citation typing, and here the sentence was, for this I highly recommend X, and it will bring you this property that we actually found on the site of ontology, which is actually the closest one to the sentence we had. So now let me go back in the slide in these few minutes that are left. Yeah, I talked about knowledge exploration. I showed you some knowledge visualization. Now I want to say these few minutes about the market uptake, and actually thanks to the review that we got from the last night, basically our weak point in the poster and in the paper was about the market uptake. And we did not include this in the paper, but actually as an organization using Sheldon, the one on the left are all entities, institutions, and industries that are using Sheldon or component of Sheldon. We have about 20K access per month. Of course, it's not that it doesn't mean that each of these entities access Sheldon each day. But I mean, it's not constant, but overall we have 20K access per month. We have one new project about robotics, is a new Horizon 2020 project where Sheldon is going to be used in the main behavior of this robot. This robot is going to be used for live assistance. We have a tender that we just won, and next month it's going to start, and we'll use also semantics provided by SHELDON to it. Hermes is an Italian industrial project which you'll use Sheldon capabilities. Prisma is another one, still in Italy. And also Sheldon is going to be used in the creation of Apache Stumble plugins, which is Stumble is a product of finished P7 project of IKS. Some use case, people interested in Sheldon, they ask us just some example. Sentiment analysis using Sheldon, using semantics, and actually we're going to participate in a similar eval task related to irony, detection of irony. Okay? Access to relation to machine reading for new components, for content management systems, access to the citation typing component, and we have started to talk with Elsevier about it. And also, yeah, about the document component, I just talked about it. And the last slide is this. It's just a SWOT analysis that we did about SHELDON. We're going to build, we are in the process of building this new UK startup. One of the members of the team has already built 3 different startups, one in US, one in Italy, and one in UK. And he has knowledge about it. Also, all the results shown here published and proved. We have a wide ICT network in Europe, and this, of course, we can leverage that. We participated in the Horizon 2020 project now in January 2015, that's going to start. We have multi-language support. We have automatic language identification. We provide REST API access. These are strengths. As weakness, initial funding, of course, is a weakness point. We need to find dedicated programmers. We are all researchers, but we need programmers. Team is not in the same physical place. We are all around Italy and Europe. This is another good point. Computational time, we just need another server, a bigger server, because if 100 people try to just access, if 500 people try to access the system all in once, then we'll have delays. But there are also opportunities. Opportunities in the fact that semantics is not really explored, at least in Italy, in Sicily, so many people can use it to improve their systems. Theft, license issue. We are struggling with license issue. They're a problem, but it's not a problem of, all the problems not related to health are solvable. So we are sure we can solve it better.
Yeah, thank you very much. Questions?
Lots of projects using SHELDON. The way it looks to me, I can see some quite capability underneath those buttons. I'm struggling to see it as a tool that someone sits at their desk and uses. It doesn't seem to go quite far enough, perhaps, towards an application area or towards it. So, how do you perceive the market or the usage of SHELDON will work? Is it through what you're showing us, or is it selling off the components through the API or something?
In the business model we envision, this is not for an end user. It's not an application. An end user can use it in order to get something that is some end product. What we're going to do is we're going to sell access to each of these components, so that, but not for a final project. Not for a final application. It's like programmers can use our products, our components, in order to build some other end user application. So we are in the middle, basically. We want to place in the middle because there are too many applications already, and the research side is actually the one who's lacking of substance. So we want to just stay in the middle and provide the core of semantics.
Okay, one more question. Anybody? No more questions? Okay, so then thank you again.